Ladies and gentlemen, time for a lesson on multiplying and dividing complex numbers. So last time we learned about this lovely little thing here called I, and I is equal to the square root of -1. And we also added and subtracted complex numbers. Complex numbers are in the form a plus bi. A is the real part, bi is the imaginary part. What we're doing today is multiplying and dividing complex numbers. And we're going to start with example 1. To do so, you treat it just like normal numbers. You just have to remember that I has specific properties. For instance, here, you got parentheses, thing in front, you just distribute it, distribute. Now we got 8i plus 36i squared. And normally you should be done there, but we have to remember that I has certain properties. When you square I, you get -1. And that's what we learned in our last lesson. And so this part becomes -1, which means it's 36 times -1, which means we're going to get 8i minus 36 to simplify this expression all the way. So now it's like this. And then we can actually put this in standard form where we put the real part first, like this. And yeah, the directions has us write it in standard format. So we'll do the real part first and then the imaginary part. So let's jump over here to example 2. When you're multiplying these, it's just like when we're multiplying when there are radicals, root 3 and root 2s and stuff like that. The first term of our first binomial times by both of those, we're going to get 6 plus 20i. And then you need to multiply the second term of our binomial in through the next binomial. And we're going to get minus 27, 27i, and then minus 90i squared. And much like on our previous one, we can simplify things that have I squared, means it's this part is equal to -1, so it's -90 times -1. And so now we got 6, and these combine, we'll get minus 7i. And then over here, this will get us plus 90, and these two guys will combine to give us 96 minus 7i, and that's in standard form where it's a plus bi. So we got that. So that's how you multiply expressions that have complex numbers. Practice section D is so you can practice that. So you can just pause the video here and work through those. Well, let's jump to the next part. So we're now moving towards dividing complex numbers. When you're dividing complex numbers, it's just like when we were dividing, quote unquote, dividing with radicals. You had to simply get rid of the radical in the denominator. In this case, we'd multiply by root 5, which will give us 10. Well, here, we'll do 2 times 5 in the denominator. And in the numerator, we'll get 3 times root 75, because remember the inside parts multiply together, and then the outside part just stays there. We get this. This does simplify a little bit. You get 25 and 3, and 25 is 5 and 5, and so 5 can come out. And we're going to get 15 root 3 on top, and on bottom we got 10, and then these guys can reduce a little bit. 5 goes into both of them, so you get 3 root 3 over 2. So when we have radicals, that's what we do. And when we have complex numbers, you do the same thing. If you have an I here, that means the square root of -1. So I can just times top and bottom by I, and make sure if there's multiple terms, you put them in parentheses. And so our bottom here is going to be 2i squared, and on top we'll get 3i plus root 15i. Our denominator does simplify. Remember, I squared is -1, so our bottom is -2, and on top we'll get 3i plus root 15i. Yeah, you need to get something like this. You can, never mind, we're not going to bother with that. So the next part, what if there's 2 terms in the denominator like this? Well, just like when we had dividing radical expressions or expressions radicals in the denominator, you have to use the conjugate again. So a reminder that the conjugate is it's the same binomial, except you change the operation in the middle. So it becomes plus in the middle becomes minus, minus in the middle becomes plus. conjugates are in pairs. They're always in pairs. And the practice section F is just writing the conjugate. Something like 5 minus 6i becomes 5 plus 6i. It's easy to just go through and write the conjugates for those. There's one thing that's awfully handy when you multiply by the conjugate, and we saw this when we were dealing with radicals, is that when you multiply by the conjugate, it gets rid of all the radicals when you have, well, two binomials. And so that's what we're trying to do. So we're going to use example 3 and 4 to help us see this. You need to find out what to multiply by. This here is 2 plus I, and so we're going to multiply by 2 minus I. And you got to do it on top and bottom because this entirely makes 1. And so we're just timesing by 1. It doesn't actually change the value of our fraction here. And so we're going to distribute along the top and along the bottom. Let me draw all these little lines here. We'll get 20 minus 10i on top. And then on bottom, we will get 4 minus 2i plus 2i, and then minus I squared. And then we do some simplifying some more. On top stays the same. Nothing's changed there. And then on bottom, these guys are always going to be opposites of each other, so they'll be gone. And I squared is -1, so the bottom becomes 4 minus -1, which is just 4 plus 1. So it's 5 on bottom, and we got 20 minus 10i. And since both of those numbers on top can be divided by 5, we'll go ahead and do that. We'll get 4 minus 2i. And now we're done with that one. It doesn't always work out like this. For instance, if this was like 3, then we would just stop here. But since it does go evenly into all 3 of those, we'll just divide them all by 5. Let's move on to example 4. Again, you multiply by the conjugate of the denominator, not the numerator. And so this is 4 minus 5i, so I'm going to times by 4 plus 5i, and do that on top and bottom. And once again, you need all these parentheses things because you have to do double distribution here along the bottom and the top. This is where your algebraic skills really come into handy. You know, you're doing a lot of multiplying, you have to keep track of everything. So on the bottom, we're going to get 16 plus 20i minus 20i, and then minus 25i squared. On top, we're looking at 88 plus, hold on, I'm going to calculate this so I don't mess up because I'm not into the, okay, we get plus 110i, and then we will get minus 28i, and then minus 35i squared. So we have all these terms on top and bottom. We just need to simplify top and bottom individually, and then we'll go from there. These guys are going to combine. This one over here, remember I squared is -1, so we can get 88. 110 minus 28 is going to give you 82. So we get 82i, and then we'll get plus 35 there. And on bottom, we will end up with 16. These guys, again, always are going to be opposite each other, so they'll get rid of each other. And then I squared is again -1, so minus 25 times -1 becomes plus 25. And so on top, we got 88 plus 35, there's 123 plus 82i. And then on bottom, we got 16 plus 25, which is 41. And I wonder if 41 does go into all 3 of those, strangely enough. 123 divided by 41 is 3. 82 divided by 41 is 2. So we got 2i, and this one, again, turns out to be nice. If this happened to be 40, then we would just stop here, but it happens to go into both of them, so we'll simplify a little bit more. And so that's the process of dividing complex numbers. You multiply by the conjugate on the numerator and the denominator. And then practice section G is all simplifying complex numbers with division. So there you go, multiplying and dividing complex numbers.